graphing y equals 2 cotangent, that's cotangent, open bracket x plus pi over 2 close bracket. The general cotangent function equation is y equals a cotangent, open bracket bx minus c close bracket plus d. Okay, so right, I'm going to sketch a tangent function first. Y equals to tan x. Tan x goes from infinity to 0 and then to infinity, positive infinity. The line of asymptote is pi over 2 minus pi over 2, and the line of asymptote here is pi over 2. So it has a period of pi. So it goes that way. Right, and then it goes all the way to infinity. So at this point here, at pi over 2, it goes to infinity. And at 0, it crosses the x-axis here. And at minus pi over 2, it goes to infinity. And these two lines are the line of asymptote. So cotan is basically, when we write cotan function, cotan of x is 1 over tan of x. So that's what cotan is. What that meant is where tan is 0 here, cotan will be 1 over 0. Now there are a few definitions for 1 over 0. So 1 over 0 is basically, if I write it here, 1 over 0 is infinity. That's one thing. But also 1 over infinity is also equal to 0. Right, for when tan is 0, so tan is 0 here, cotan will be infinity. So that means the graph will be approaching 0, but never touches x equals to 0, because this is a reciprocal of that. So the line of asymptote is now not pi over 2 here, but rather 0. So now we can draw the line of asymptote here. I'm going to use a red pen so you can see that. So it's 0 for cotan, because 1 over 0 is infinity. 1 over 0 is infinity. And therefore, this will be the line it approaches. And then what about pi over 2? Well, pi over 2 is infinity for tan. So 1 over infinity is 0. So that means it's going to cross 0 for cotan. And then what about minus pi over 2? Again, it's infinity for tan. It's going to cross for cotan here. See, 1 over infinity is 0. So this is infinity. So 1 over that will be 0 for cotan. What about pi? Well, pi for tan, a line coming from there going through 0. Infinity here for tan, coming from infinity to 0 there. For cotan, it will be approaching infinity there. So when we draw cotan, it's going to come from infinity all the way to 0 there, and then approaching infinity at pi. So that will be infinity there. Oops, it's infinity at pi. So pi is the line of asymptote for cotan. Pi is the line of asymptote for cotan. What about minus pi over 2? Well, So again, minus pi is also the line of asymptote for cotangent because it repeats every pi, just like tan repeats every pi. So we draw a line of asymptote here and just hidden line, that's all. So that's the line of asymptote, which means the curve is coming from here and crossing there and approaching the 0 here. So that's the line of asymptote coming from there and approaching 0. So that's the parent cotan and that's the parent tan. And that can help us sketch that function. Just remember tan here, where it crosses 0, will be the line of asymptote for cotan. And where it comes to infinity will be the line of crossing for cotan. The amplitude for this function, there's actually 2 is meant to be the amplitude, but you can see the cotan function goes to infinity, so it doesn't have any cap. So therefore, the amplitude here is none. What the 2 is doing, it's speeding the curve. That means it's making it skinny, so it's going faster. If it's a half, it will be broadening the curve, then the curve will be going slower. So second point to look at is period. Well, period is pi over b. So period is pi over b for tan and cotan, but for sine and cosine it's 2 pi over b, and b in this case is 1, so it's just pi. The next point to look at is scale, x scale. The next point to look at is x scale. For x scale is going to be period over, well, you can see it's got for every period there's 2 line of asymptote, so divided by 2, and that would be, period is pi, so it's going to be pi over 2, which means you're adding 90 every time. Number 4 is phase shift. So phase shift, we look at the start and we set the bracket to 0. At the start, we say x minus plus pi over 2 equal to 0. And that would be, therefore, x will be equal to minus pi over 2. So you can see it's going to start at minus pi over 2. And the end of the graph will be, so we could look at the end as well. So we said x plus pi over 2 equals pi, because it's every pi, the period. And then you can get x equals pi minus pi over 2, which is pi over 2. Any vertical translation, no, there is none, because vertical translation vt is 0 here. That's plus 0. That's d here, which is plus 0. So there's no vertical translation, which means the curve will lie on y equal to 0. Any reflection? So that's number 5. Number 6, any reflection? No, because there's a positive here. If it's negative, then it will be reflection. If that is minus 2, then it will be, the minus will make it reflect along the x-axis. Okay, now to sketch the graph. Now you can see this is a shift now. It's shifted by minus pi over 2. This is the original tan function. It goes through pi and then it's shifted. So this one is shifted by not pi, but minus pi over 2. So that means it must have gone, this must have moved to there. And That means it's starting at minus pi over 2 here. So that must have moved to there. So that means it's going to go through 0 here rather than that, because it's shift by minus pi. So now to sketch the curve, you can see when we set this to 0, here it was the line of asymptote, right? And the line of asymptote was 0, so that's good. That's for cotangent. X equals to 0 at the line of asymptote, and x equals to pi at the line of asymptote. Now we set the same thing here. We set the x plus pi over 2 to 0, so that will be the line of asymptote. So that's the line of asymptote for that curve. So we draw the line of asymptote there, because it's minus pi over 2. So that's the line of asymptote. So instead of being 0, it's minus pi over 2. And at the end of it, the line of asymptote here for a period is pi over 2. So now the line of asymptote is also pi over 2. Right. So what that meant is the curve goes through 0, and so it's coming from there, and it just goes through 0. So what's the function of the 2? Well, the 2 is just making the curve slimmer, so therefore it travels faster. And if the A is between 0 and 1, so if A, let's write it here, if A value is between A less than 1, it will make this curve here broad, so it'll be broader, so it'll be much wider. So that means it will travel slower. But if A is greater than 1, it will make the curve skinnier, so that means shrunk. So A greater than 1 will shrink the curve, and A between 0 and 1 will stretch the curve horizontally. And when you shrink in horizontally, when you shrink A. When A is greater than 1, it will shrink horizontally. When A is between 0 and 1, it will stretch horizontally. So we could do another period by just basically drawing the line of asymptote at 3 pi over 2. So that would be the next line of asymptote here, because it's every pi. The curve will be going through pi. So again, it will be coming through there and going there. So that's the 2 period function. If you want to plot the third one, it will be going that through, so going through minus pi here, and it will be going through pi here. So it will be going through pi there, and or approaching pi, 3 pi over 2. This is minus 3 pi over 2. So this is the curve for y equals 2 cotangent x plus pi over 2.